Welcome to Engineering Visualization channel. So today we are going to solve model question paper 4 problems. Okay, so watch the videos till the end. You can able to understand all the 4 problems. So each one of the problem I'm going to solve using solid software. Okay, all the 4 problems. So in this question number 1 given points and lines problem, second one is solids, third is isometry, fourth is development. So subscribe to my channel and share to your friends and classmates so that they can be benefited, and hit on the bell icon for the latest notifications and hit on the like button. Thank you all, and watch the video till the end. You can able to understand all the steps. Thank you all. Projection of point problem. Okay, this is a solid edge 2024 student version. Okay, first I'm going to draw an xy line. Okay, so we can make use of this video so that many of the students have been asked for the solving the model question paper of the CAD. Okay, for them I'm doing this. So guys, please make use of it. Okay, subscribe to my channel and share to your classmates and friends so that they can be benefited. Okay, so here with respect to the question here, so in the question what they mentioned here, so it is resting on the HP plane, say resting on the XY line. So you can see the question, a point A is on HP means it is nothing but the front view. That's why I have put a point and mention A dash. Okay, and now the length we should consider. So here the point, it is the top view lying in the first and fourth quadrant. In both first and fourth quadrant it is lying below the XY line. So that's why I'm drawing the length of 30 mm. So below the XY line. Okay, you can just see first and fourth quadrant, so it is below the XY line. That's why I am putting it and mentioning it as A. Okay, now after that see the question, can change the thickness here. Okay, this is a new version of the software, that's why I'm getting a little bit of time because the commands were of different type. Okay, so if you want this software I can share this. Okay, this is the, for top A it is 35 mm drawn, and then if it is another point B is on VP. On VP means it is nothing but the on VP means it is nothing but the top view, and below HP. So below HP means we don't know how much distance it is. Okay, what they mention here, it is the line joining the front views makes an angle 30 degree to XY, while the line joining the top views makes an angle 45 degree with XY. So that means we should connect with the top views with an angle of 45 degree, front views with an angle of 30 degree. Okay, that's what given in this problem. Using this sentence we have to draw. So what I'll do is, here I'll be connecting the top views at an angle of 45 degrees. Okay, so from the top view I'll be drawing an angle line for a length of 45. So here just by randomly we can draw, and then we can change the angle here. So first I'm drawing one line. Okay, and I can change the angle here, can change the thickness. Okay, so select the line and select its thickness as 0.13. Okay, now here I'll change the angle. Now you can see here I'll go to angle between. So before that I'll be drawing one smaller horizontal line here from at the top A. Okay, so go to angle between and select the angle between these two lines, and angle you're getting in. Now we can modify, change it to 45. Yes, now it has been changed. Okay, this is what the top view connecting the angles. Okay, an angle of 45 degree. So you can see the question here. So another point B is on VP. On another point B is on VP means nothing but the top view, and it should be drawn on the XY line. Okay, so we know that the top views are connected by an angle of 45 degree. So from the top view of A already we have drawn an angle line at an angle of 45 degree. Now I'll put the point. So that top view we should be marking on the line passing the 45 degree and on the XY line. Okay, So the intersection of this 45-degree line and on the XY line. Now what I'll do is we'll be drawing another line which is of angle 30-degree. Okay, that is for front views like this. Yes, downward I'll be drawing it. So just randomly I'll draw it, and then after that I'll change the angle. Just randomly can draw here. Don't worry about the length. Now we can change the angle. So this angle should be 30-degree. Okay. Now you can see the top view on VP means nothing but the top view. It should be drawn on the XY line. Okay. Another point is on VP and below HP, and they have not mentioned any distances, right? So we can put the point here. Go to point and just change the thickness to 2 mm. Okay, and here I can put S here. Now vertically downward is another point. Now we need to draw with the vertical line here. Yes, you can change the thickness of this line. So I'll be making it as 0.13 mm. Change it to 0.13 mm here. Okay, you can see here we should mention the points here. Okay, now mention the views here. So here this point is exactly B, small b, and this is B dash. You can see the top views are connected by angle 45-degree and front views are connected by angle 30-degree. Now we have to find out this distance. You can see what they mentioned. Find the distance of the point B from HP. Okay, so that distance we need to find out. So we just measure it using smart dimension. So that completes the problem, guys. Subscribe to my channel and like the video. So PQ given 85 mm long has its end P 10 mm above HP, 15 mm in front of VP. The top and front view are given, that is 75 and 80 mm. Using this we have to construct. So initially I have drawn an XY line here, VPHP drawn. Now we have to draw these locus lines. I'll be using offset command. So select the XY line and give the dimension 10 mm. In the same way again you select XY, give the dimension here 15 mm. Okay, now we can see that the apparent length given here. So apparent length okay, so this is we consider as a end points. Using this 75 and 85 mm, we have to draw the true length. First I'll be taking this apparent length in top view, okay, giving 75. So from this end I'll be drawing a vertical straight line. So from this end I'll be measuring for length of true length we have to give. Okay, go to arc by center, give true length 85 and cut the arc. Okay, because apparent length when it is rotated and projected we get the true length here. Okay, now you join from this end point to here. Okay, now at this end point of the line we can draw the locus line. So we can measure the length. It is 85, that is true length. So here at this end point you can draw the locus line. Same way the apparent length in front view dimensions we have to use. So the length given it is 80 mm, 80. Again go to arc by center and take the true length 85 mm. From the end points you cut the arc. And we join this cutted point with the end point, you will get the another true length. So here at the bottom below the XY line also we have to draw another locus line. Now go to arc by center. By measuring this 75 and 80 mm upper end lengths, you have to draw an arc to draw the upper end lengths. First select the 70 mm length, cut an arc. Same way for 80 mm length, cut an arc. Okay, now go to line and select thick line 0.50 mm thickness. So upper end length you always show with the thick line. Okay, now we can measure the lengths and angles. You can see this, that is the upper end length in front view 80 mm and upper end length in top view it is 75 as it is given in the question. Okay. And you can show the angles here. You can subscribe for the channel and hit on the bell icon for the latest notifications and share it to the maximum students so that they can be benefited. Welcome to Engineering Visualization channel. Today we are going to solve problem number 2 from projection of solid in model question paper 3 VTU computer aided engineering drawing. So I want you people to watch the video till the end so that you can able to understand step by step procedure how we are going to complete this projection of solids. In that we have the hexagonal prism problem with bit angle. Okay, so you need to follow each of the steps one by one. You can see in this video I am able to solve this problem within less than 15 minutes. Okay, so what is given in question? Hexagonal prism 25 mm side of base and axis 60 is resting on one of its edges of the base on HP plane. Draw the projection of the prism when the axis is inclined to HP at 45 and VP at 30 degree. That means angle of inclination in this problem they have given with respect to axis for both HP and VP plane. So that means it is an bit angle question. Okay, that means in this problem we need to find out the bit angle. Okay, first we need to, okay, in order to understand this problem completely and want to see the similar type of problems, okay, subscribe to my channel and hit on the bell icon for the latest notifications. Okay, now the same problem I'll take from the solution book like this. Okay, like this we need to construct in the solid software. Okay, why I'm completing this problem in solid software means, so 80% of your marks is there in the solid software, that's why I'm not doing the sketching. Okay, xy line it is written. Now we need to construct the hexagon using polygon by center command. with respect to the edge here. So construct the hexagon, take smart dimension, give the length 25, it will change. Okay, now write the notation, top views and bottom view notations. Top views notations are written with ABCD, and bottom face notations are written A1, B1, C1 like that, but it should be written within brackets. So here we need to find out the center of the hexagonal prism. So for that at least one or two lines need to be drawn, because since it is a prism, to find out the center of the axis no need to draw all the lines. And here inside of this hexagon we should be drawing the thin lines. No need to draw the thick line, thin line should be drawn here. One or two lines is enough. Okay, you can see in this problem I have drawn the three thin lines. Okay, since it is a prism, we should be drawing only the thin lines, not the thick lines, and mention O1 and close the bracket. Now draw the projection lines upward to complete the front view. So draw the projection lines upward here now. So axis of the prism, it is 50 mm. 50 mm length. Okay, enter. That is also 50 mm. So okay, so write the front view notations, so which are visible from the front view, so mention it. So from the front view, A dash, B dash and C dash visible, D dash, E dash and F dash not visible. So not visible means we should write within brackets. Same way for the bottom face also we write the same thing. So now we need to copy the same diagram using move command. Okay, and we need to incline with the base head. So inclination to base head is given. So actually they'll give angle of inclination to the axis, but we need to incline with the base edge inclination. Okay, it will be easy in order to do the inclination. So use the move command, creates a copy, slide along the XY line and go to rotate and take the base edge. Inclination, it is 45°. So incline 45, so it has been inclined. Okay, now extend the axis, find out the angle and project downward. To complete the second position, top view. So draw the projection line downward here. Draw the projection lines downward to complete the second position top view. Guys, subscribe to my channel and share to your friends and classmates so that they can be benefited, and hit on the bell icon for the latest notifications. Okay, write down the namings now. First I'll start from the bottom face. Now I'm writing for the top face, that is A B C D E F. Okay. Now first we know that to construct the second position top view, first we have to draw an outer boundary line. Guys, you can join to my channel by rupees 119 per month, and then you can cancel after the examination. Now from the top face it is visible, so complete the hexagonal face. It is visible from the top face. So drawing the hidden faces with the dashed line. Okay, finally there is an axis. You can join from O1 to O. So it is in beta angle problem. We need to find out the beta angle in this. So the procedure is simple. You need to draw an angle line first. So angle it should be drawn for 30 degree. Okay, you can modify it just by doing like that. Okay, select this entire thing and then you can move it. First arc length of 50 mm we have to cut. Okay, 50 mm cut the arc. So draw the locus line. Now take this length of O1, 35.52. So cut the second arc length on the locus line. Then join using axis. Now we need to copy this second position top view and transfer using move command. Okay, project it upward to complete the final position. Thank you all. Thank you for watching the video. You can subscribe to my channel and hit on the like button and hit on the bell icon for the latest notifications. Thank you all. Thank you for watching my video. Complete the final position. Is placed coaxially on top of a regular hexagonal prism of base side 30 and height also out of the axis 60. That means first I should construct this hexagon. That is first I have to draw the orthographic top view. So remember it, for the polygons such as triangle, pentagon and hexagon, we should always construct the orthographic top view, because you require box dimensions in order to construct it. Okay, change the dimension to 30. Now using this box dimension, okay, we have constructed the box. I have to show the box dimensions. Okay, so for the hexagon box with the box dimensions constructed, now I'll be constructing the orthographic of it. Take a reference line. Okay, so from this reference line, so construct a box for a length of 51.96. that is what the first length, 96, and angle 30 degree. Okay, the second length is 60, angle is 150. Again the length is 51.96, angle is 210. Okay, now join. So box it is constructed. Now we have to cut the arcs. Okay, for a length of 51.96 we will be cutting an arc of 25.98. Take the radius and cut the arc. The same way in the opposite side also I will be cutting for the same arc length. Okay, that is 25.98. Give the radius 25.98 and cut the arc. Okay. After that, at the edges we have to cut a arc length of 15 mm from the corner ends. Okay, 15 mm. From this side also 15. Cut it. Same way from here also. Cut it for 15 mm. Same way you can do it here. Radius of 15. Okay, now go to thick line. Now connect all these points. Okay, that's complete the bottom of the hexagon. Now we have to consider a vertical height of 30 mm. You can see 30 mm length of the axis. So height should be 30. First I will be drawing the vertical line from one reference end 30. Okay. We'll go to move command. It's a copy. Select the corner end and then place it with respect to all the corner points. Okay. Now using continuous line, I'm going to join all these corner points. Okay, so that completes the hexagon. Now exactly at the center of it we have to place the cone here. Okay, so to place the cone here separately, what I'll do, I'll be constructing the hemisphere, that is ellipse of dimension 40 separately. You can see the right regular cone of base side 40 mm. Okay, on one side I will be constructing by taking length. The length will be 40, angle is 30, and again length is 40, angle is 150, length is 40, angle is 210. Okay, good morning all. So in this problem, this is problem number 2 from solution book. So in this problem you have to construct a square prism of base side 30, axis length 60. Okay, resting on HP with all the vertical bases inclined to it. Okay, so we have to construct the development of this. Okay, first I will be constructing a square prism, okay, of dimension 30. So before that I will be drawing an XY line first. Okay, so here you can see I am drawing a square here, square of dimension 30 and angle 45 degree. Okay, you can show the dimension for one side, you can write the namings. So we have to write the namings in small case letters. Okay, So doing the projection line, so drawing the projection line here. Okay, the front view axis length it is 60 mm. It is a square prism, means we have to get a rectangular face in the front view. Okay, so the front and top view of the square prism, front and top view of the square prism, it is done. Now we can show the dimension. Okay, so now we have to draw the section plane which is there at a height of 50 mm from the base. Okay, and it is exactly cutting the axis at a height of 50. So for that I'll be drawing a 50 mm line from the base, exactly from the center. On the axis I'll be drawing another 50 mm line. Okay, so go to line. So from the bottom I'm going to draw, that will be convenient. Okay, 50 minus 10, 60 minus 50 means 10, but I will be drawing from the bottom. Okay, so from the bottom 50 mm length, so I've drawn one line for reference, and then I'm drawing a section plane, taking this as axis plane, now giving the angle 60 degree. Okay, so that's what you can see, that angle of inclination will be 60 degree here. So type 60 and enter. Okay, so after this go to next and extend this line. Okay, this is where it is cutted. Okay, this is how it is cutted. Now we can show the angle for this section plane. Okay, angle of inclination it is 60 degree. Now we have to, we can give the naming here. So that is 1, it is where it is cutted. Again on the A point it is 1, again here same on the A edge. Now 2, point number 2, it is falling on a vertical edge B. Okay, and then point number 3, you can see it is not falling on the C, it is falling somewhere in between B and C. Okay, somewhere in between. That's why I'll be drawing a projection line from this intersection of these 2 points. By projecting it, you can see this is not falling on the B, it is falling in between B and C. So that's why we have to draw another line here. I'll be making that line as a continuous line. So we can give that is 3, and here you can see again, if I write the point number 4, so that is not falling on the D, it is falling in between C and D. Okay, that's why point number 4. Then point 5, it is falling on the exactly on the vertical edge D here. Okay, now we have done with the namings. Now we have to project it. You can see that. So we have to project it. Okay, so so I can use the split command to highlight only the retained cut portion. Okay, so for that I'll be using the this split command. Using the split command we can split it exactly where we want to make the lines dark. Okay, we have to dark only the portions which has been cut by the section plane, the retained cut portions. Okay, so other lines I'm going to make it thin lines. Okay, thin lines. By selecting these lines, I'll be making it as thin lines. Okay, now we got it, the cutted portion. Now we have to do the development. So draw the projection lines from here. Okay, so draw the continuous line here. Now we take vertical edge, because this is a parallel line method, because it is a prism. So draw vertical line. Anywhere you can take a straight vertical line. Okay, now here you can see the dimension, it is 30. Totally there are 4 faces in the square prism. So using the offset command, I will be giving the distance of 30, and then I will click for 4 times. Okay, I will get the 4 faces here. I'll make all these lines as continuous. Okay. Okay, now we can see by projecting the from point 1, so I am getting point number 1 on AA. So, okay, so I can do that. So you can say first we have to write the namings A, B, C, D, capital A, capital B. So that indicates we'll get the exact vertical edges A, B, C, D, A. And now we can give the namings 1 and 1 we are getting on the vertical edge A. Okay, and the vertical edge B we having a point number 2, that also we can project it. Point 2 and 5 we are getting on the same point, but I'm not getting the intersection here, so I can use the split command here so that I can get the exact point here. I'll go to split command and split it exactly where the section plane is cutting. Okay, so now I'm getting the exact point. From here I'm going to project it high. Welcome to Engineering Visualization channel. Today we are going to solve model question paper 5 VTU computer aided engineering drawing. Okay, here in this question they are given question number 1, it is rectangular lamina, question number 2 hexagonal prism with appears to be, and here question number 3 they have given to complete the orthographic projection of this object. Okay, so for this particular problem I have done the top, front and side views, so please go through. And problem number 4, it is cube problem. Okay, you can see this. In order to see more videos like this, you can subscribe to my channel and hit on the bell icon and watch till the end. Width give 30 and height 20 and place it with the shorter edge here on the VP plane. Okay, so measure the dimensions. Okay, write down the notations and draw the projection lines to complete the top view. Okay. So here B and C end not visible, that's why B and C written within brackets. Select the top view, go to move command, creates a copy of it and slide along the line, and now we can give the inclinations. So inclination to the VP. So here I'll give angle of inclination 30 degree. Okay, so inclination below the XY line means minus 30 we have to give. Okay, draw the projection lines to complete the second position front view. And write A dash, B dash, C dash and D dash. Go to thick line, okay, second position top view completed, and trim it off these extra lines. You can see now longer side of the plane is inclined at dash degree to VP. That means we should take that longer edge and we have to give the angle of inclination here. First I'll be drawing an angle line. Okay, angle of inclination here I'll give 45 degree. I'll select this second position front view. Okay, creates a copy of it and select the vertical edge here. I'll select this B dash, go to rotate, select this B dash to C dash and place it on the angle line. Then project downward to complete the final position. Complete the final position by joining with a thick line. So this completes the problem. Problem number 6 from the respect to edge here. So hexagon of dimension 25. So make sure this icon maintain relationship has to be on. Then use polygon by center, 6 sides. Okay. With respect to edge. So give the naming C D E given in bracket. After this, we draw the thin lines to find out the center of the axis. Okay, that is diagonals we are going to draw. That is O. Okay, now here axis length is 15. So we're able to see B dash, C dash, dash in bracket. Able to see O1 dash and dash and O dash also not visible. Okay. So now 45-degree inclination to HP. So we are going for base edge inclination. 19 minus T5 equal to 45. So we have to incline this with respect to the base edge. Okay. Angle of 45 degree. Then extend extend command can extend the axis and find out the angle of inclination. A1, A1, C1. So here projection line. Hello? Sir, hello? Hello? Sir, email form was there. The person came. Sir, how can you not be please approve. Please other sir, members. ಸ್ವಲ್ಪ okay, so first we have to construct an outer boundary line. This section of this it is visible from here. And this rectangular face also visible. This hexagonal base not visible from the top view, so it is written with the dashed line. Okay. Here from this slanted rectangular edge also not visible. You can show part of the line here from here to here. Now 40-degree angle line. So angle we have to give that is 120-degree angle. Minus one second, thank you. Sir, actually, ನಾನು you have to have here 40-degree, 40-degree Then we have to select it. Okay. Axis line here. So select this diagram to create it. So I can take it a little lower. Can give the naming. Another projection line. V1 dash, V1 dash. So here are two nearest point to exponentials E and F. Okay, E to D, E to F, and F to J, and F to F1. Like that, first we construct the dashed lines. rest of the diagram it is written with a continuous line. The slant edges. Finally, axis. Good morning, all of you. So you can see in this, this is what the isometric component given. So we have to construct the isometric views, that is front view, top view and side view. You can see this is your isometric. Isometric means it is nothing but the 3D view of the component, okay, wherein it will show the dimension both in x, y and z direction. Okay, isometric means it is a 3D component. Okay, but the orthographic means, so it is the individual views. You can say the top views, side view and front view. So the separate views what we get, that what we called as your orthographic views. Okay, here we need to convert this isometric into orthographic. Okay, that's what we have to do in this problem. Okay, you can see there is a front view exists, there is a front view, side view and top view exists. So we have to analyze each of these views and we need to construct all these front view, top view and side view. Okay, they have mentioned in the question front view looking from x means that is your front view. So then you can see there is a top view exists. Okay, and there is a side view. So we will be constructing each of these views one by one. Okay, so first I'll be constructing xy and x1 y1 line. So thereby I'll be dividing the regions for both top view, front view and side view. Okay, so here I'm drawing xy line. So I'll be mentioning xy. Okay, I'll be mentioning x1 y1, that is profile plane here. Okay, that is x1 and y1. Okay, now we need to analyze. So we can write this here. Here I will be constructing the front view. That's why I've written FV. And here I will be constructing top view. And here side view. So that's what the short notations. Otherwise I will write the full thing. Front view. Okay. Top view. Top view. And this is our side view. Okay. Now we have to analyze the isometric. You can see in this isometric, so this is our front view. So which are the faces visible from this front view? We need to analyze. I will write it. This is our front view. So this is our top view. So we need to look at this this component from the top view. That's why it is top view. And this is where we get the side view. Okay. This is we have the side view. Okay. So you can mention the shortcut also. Okay, in the next problems I'll be mentioning shortcut, that's why I'm writing there. Okay, you can analyze from the front view which are the faces visible here. You can see I'll be constructing there front view, top view and the side view. You can see the front view and side view always adjacent to each other. Okay, adjacent to each other, and then top view and front view will get in a vertical collinear line or a plane. Front view always adjacent to the side view. In order to connect the top view with the side view, we draw 45-degree angle line. Okay. So now I'll be analyzing the front view. So to analyze the front view, which are the faces visible, I'm going to shade it. Okay. I'm going to shade it. So this is how it is easy for us to identify which are the faces visible from the front view. You can see that L shape is visible from the front view, and then this rectangular face also visible from the front view. I'm shading it. Okay, and this face also visible from the front view. Okay, so these three faces are visible from the front view. We need to draw. You can see the length of it, it is having 104 mm, and the height it is having 48 mm. So that means we can construct one rectangle with 104 and 48 mm with thin lines. Okay, so I'll be drawing a line here, horizontal line for 104 mm. You can see all these dimensions were in mm. Okay, so 104 mm. So the height here we should get, that is 48 mm. Okay, so mention 48. Okay, and the same thing we can do it. As I mentioned, we'll be constructing a rectangular face. From there we are going to dark the things. Okay, okay, so now you can see, analyze this front view. Okay, front view. So we need to have a dimension here. You can show the dimension which we have constructed a rectangular face here. Dimension of 104 here. We can mention that. Okay, 104, and this is, we have 48 mm. Okay, height. Okay, so now you analyze the diagram. So in the diagram you can see the L type shape component we should get, and it is having a height of say 16, and from there it is having a dimension of say 24. So we can mark here 24 and then 16, like that we can do. So first I will be doing 24, marking for 24 mm, and then vertically downward I will draw a line. So mark for 24. Okay, then vertically just draw a straight line. Okay, and then here from this end we should exactly cut it at a height of 16. Okay, so here also I will drawing one line horizontally. Okay, okay, and then we need to extend by 16 mm as it is mentioned. It's like steps. Steps were there exactly at 16 mm height. Okay, can construct that. So you can see here, we will erase this part. It is similar to L shape. Okay, we will erase that. Now we should dark the faces which is exactly visible from the front view. Okay, we should dark it. So these are the faces. This is how it is exactly look like in front view. Okay, in the front view. So we should dark that. Okay, okay, now we need to construct the, can show the dimensions. Okay, it is, so showing the dimension is, so it is having dimension of 24, and this is having a dimension of 16. Okay, all these three steps are having a dimension of 16. However it is there in the front view, we are showing the dimension. Okay, so dimension of, okay, 16 we should mention. Okay, so we will draw project the lines here. We will draw the projection lines downward to draw the top view, because we know that these things are occurring in collinear. Okay, now we see the top view, so which is looking from the top. So from the top view we are able to see, okay, we are able to see this one. I am going to shade it with the straight lines here. Okay, this face it is visible from the top view. By looking from the top view we are able to see this one. Okay, I'm just shading it with the straight line here. Okay, and this face also visible from the top view. Okay, okay, this is what it is visible. You can see, so it is having a length of 104, and then it is having a width of 72. 100 by 72 we should construct a rectangle here. First I will construct that 100, and then I will take 72. Okay, so 104 we already have it here. 104 already we have it here. So you can just draw a line. Okay, so draw the lines straight so that we get the exact dimensions. Okay, make sure you draw the straight lines. So 104, draw one line, and then another the width we should have it here, that is 72. So we'll erase this. Okay, okay, so you can show the dimensions. So one side we know it is 104 and the other side we have it is 72. We show the dimensions here. Okay, so it is having a dimension of 72. Now we can see, so we will take up that. Okay, you can see it is like L shape we should get. Okay, first I will construct that L shape. So you can see both the sides are having a space of exactly 24. So we will mark that first. Okay, 24 exactly, 24 you can mark it. Okay, here also you can mark for 24. Okay, then draw lines here. So where they are intersecting we get the L shape here. Okay, okay, the L shape is done. Okay, now you can see each of these rectangular faces having the dimension of again 24. So we can mention it. So it is 24. Okay, so this completes the top view. So we should dark it. Okay, now we can mention dimensions here. So each of these top face having dimension of 24. Now we have to draw the side view. You can see like side view we should construct. Okay, so you can see this is what I will be shading that with the help of dots, the side view. Okay, that we will get a clear understanding of it, how to do that. Okay, so you can see adjacent to the front view we have the side view. Okay, I'll be drawing the projection lines here. Okay, okay, in order to connect the side view with the top view we should construct the 45-degree angle line. So this concept you all know it. To connecting the top view with respect to side view we should construct the 45-degree angle line at the intersection of x5 and x1 y1. I'll be placing the protractor and marking for angle 45 degree. Now draw an angle line passing through this 45 degree. Draw a straight line. Okay, so this having an angle of 45 degree. Okay, now project the lines from top view till it touches the 45 degree angle. Okay, you can see in this problem there is a cube given. Dimension 40 is resting on HP with its base on HP such that one of its vertical face inclined at 30 degree to VP. That means we have to draw 30 degree. Then we have to place the square of dimension 40 on it. It is cut by a section plane perpendicular to VP inclined to HP at an angle of 45 degree, and it is passing exactly at the midpoint. You can see if the length it is 40, so you have to take 20. The midpoint you have to draw 45 degree section plane here, and we need to draw the development of the lower lateral surface of the cube. So first we will be constructing an XY line. So here XY line you can take the thickness, either you can take 0.25 or 0.13, no problem. Then you can mention XY line VPHP because it is in first quadrant. Okay, you can mention that. Write XY and VP HP because this is in first quadrant, so in the development also we are using the first quadrant only. Now you draw an angle line, so here you should draw an angle line for 30 degree. So 30 degree means below the XY line you should give an angle of minus 150. Okay, 150 if you give the angle, you get it here 30 degree. You can measure the angle by using angle between command. Okay, so you will get the angle 30 degree. Now you have to take the square of dimension 40, and then we have to place with respect to that vertical edge. So you can give the width and height same, that is using rectangle by center command, width 40 and height also 40. The angle you can give, that is 45 degree, so that it is easy for us. So when we place it on this 30 degree angle point, now we select this and go to move command and select the end point here, and then place it on this angle line. Okay, and then go to rotate, and then again you select this whole thing because this entire thing you have to place it. So select the again end point from one end to another end, and then place it on the angle line. Okay, now after this, so we can draw the front view of it. So front view also having 40 mm dimension because it is a prism. So we can write the naming for it, A, B, C, D. Only top face notations we can write. Okay, we're not writing all the face here. We can show the dimension here. It is 40 mm. Now we can project the line. From the end points. Okay, straight projection lines you need to draw. Okay, you can zoom in and check it. Sometimes you are unable to do it. You can zoom in and you can do it. Okay, now you can see the height also, it is 40 mm. So we will be constructing for height of 40. Mention it. Okay, you need to draw exactly for 40 mm here. Then you can join. Okay, show the dimension. Can give the naming here, that is A, B, C, D, the vertical edges. Okay, now you can see here we have to draw an axis. So for that I'll be drawing the thin lines here, that is diagonal lines, to find out the center. Okay, and then I will draw an axis in the front view also. So I will draw thin line here because it is in prism. So cube is one of the prisms, so remember it, the inside lines we are drawing, it should be thin lines. Okay, it should be thin lines. You can mention it as O, and then you project it upward. Okay, and then from there you can you can draw a axis line here. Okay, okay, now exactly at the midpoint I'll be splitting this axis line so that we'll get the midpoint of the axis, because we have to draw an angle line exactly at the middle point of it. So we need to split it exactly at the half here. Use the split command, click on the axis and click on the midpoint. So it will get split into two halves. You can choose the dimension for the lower part, so it will be exactly 20 mm. Okay, now you take a line, section plane, we have to draw an angle line for an angle of 45 degree here. Okay, you can give the angle 45 degree, enter, then you just draw a straight line. So we need to draw an angle line. Now using extend to next command, we can extend the same section plane downward also. Okay, so it is extended. Now you can show the angle. You can see that we have done. Now I'll be darkening the retained cut portion. Remaining cut portion we should make it dark. Okay, the upper part of it I'll be making it as a thin. Okay, you can see wherever the section plane has been cutted, from there I'll be drawing a projection line downward. Okay, projection line downward I'll be drawing it. From there, wherever the section plane we are having it, we are not going to draw. Where we don't have the vertical line projecting downward, in those cases I am drawing a straight line here. Okay, vertically downward. Okay, now the upper cut part will make it as thin line. Okay, lower part we should make it as a thick line. Okay, so you can again split, if it is not splitted properly, you can split it and make that upper part, because we need to draw the development of the lower portion, so we should make sure that lower part should be in dark. Okay, now you can give the numericals number where we have cutted the section plane. Okay, this is where actually cutting started, so I'll mentioning this as 1, and it is occurring in between the vertical edges of A and B. So this is 1, and I'll mention this is 2. So the point number 2, it is exactly occurring at the end B, and then point number 3. So point number 3 we are getting exactly in between B and C, that is your point number 3. If we have drawn in a straight line projecting downward, you can see the point number 3 we are getting in between B and C. Okay, and that is our point number 5. So you can mention it. So this is 3, and this is 4, and this is 5. Okay, so 5 we are getting exactly on the vertical edge D here. Now we have to draw the development of this. You can see this, and this is exactly 1. Now we can see in this top view, I am going to measure this length. In order to measure it, before that I am going to split it to the exact length so that we can able to measure it, and the same length we can cut it in the development part. Okay, using smart dimensions we can able to measure the dimension of it. Measure exactly the length which we have cut it. You can see in both the cases we are getting exactly 8.45 and 14.64. Okay, so now we draw the development of this. So we're drawing a parallel line, a thin line here. Okay, a straight line. We'll draw a vertical line here. Now using offset command, I'll be taking 4 faces here at a distance of 40. Okay, from that vertical edge I'll be considering a distance of 40. Enter. So the wrong side I have considered. You need to consider on the right side. Okay, 40, enter, click OK, and then you get the 4 faces here. Now we can mention the naming for it. It is capital A, capital B, capital C, capital D, and capital A. And now we can see here we need to mention this wherever we cutted the section plane with the number, should mention from A to 1 on the line AB it is 14.64. so I'll be taking arc by center point from the A point. I'll be measuring the length of 14.64 and cutting the arc. So cutting the arc, this is your point number 1. Okay, now we can see point number 2, you're getting exactly on the vertical edge B here. So for that I'll be drawing a horizontal line, so till here B. So this is the point number 2. Okay, and now for the point C,